Hello everyone. In this video, we'll be solving problem 36, valid Sudoku. The problem statement is, we are given an n by n Sudoku board. We need to determine if it is valid or not. If you're not familiar with Sudoku, the rules are that each row must contain digits 1 to 9 without repetition. Each column should have the same, that is 1 to 9 numbers without repetition. And each 3 by 3 sub boxes in the entire 9 by 9 grid should have the numbers 1 to 9 without any repetitions. So if the board satisfies all of the three criteria, it is a valid Sudoku. I hope you are able to understand this problem statement and the rules to solve Sudoku. Now let's switch to whiteboard and discuss this in detail. As we have already identified, there are three entities of this problem: rows, columns, and boxes. As we want unique elements in each of the rows, columns, and boxes, the best data structure to use here is a set, as it offers O of 1 time complexity for lookups. To solve this problem using set, we'll create three collections of type array of sets for rows, columns, and boxes. Iterate through all of the elements in the input board and check if each of the value exists in the corresponding collection in rows, columns, and boxes. If the value already exists for the corresponding row, column, and box, we can simply stop the iteration and return false. Else continue the iteration through all of the elements on the given board until the end, and if no such duplicate values are found, return true. As the board size is 9 by 9, we have 9 columns, 9 rows, and 9 boxes. So the collection that we are using for rows, columns, and boxes will also be of the same size, that is 9 by 9. And each row in the collection represents the corresponding row, column, or box. So all of the values in that record should be unique. Let's do a couple of runs to get a better idea. Starting with the first element 5, the corresponding position is 0, 0, that is 0 row, 0 column. In the rows collection, we don't have 5 for index 0, so we'll add 5 to it. Similarly, for the columns collection, we don't have 5 in column 0, so we'll add 5 to it. And for box 0, as the first element is in the first box, that is 0, so we'll add 5 at the 0th entry. Moving on to the next element 3, the corresponding position is 0, 1, that is row 0, column 1. Repeating the same check as before, and we'll add 3 to row 0, column 1, and box 0. We'll repeat the same process for all of the elements in the grid when making sure the values are not being repeated. This is a valid Sudoku board, so the output will be true. Let's alter the board and make it invalid to cover that case. I have added one more 5 to box 0, making it invalid. So let's complete the iteration for all of the elements before that so that we can process 5 at the end. Moving from left to right and top to bottom, I have processed or added all of the elements before 5. Now my pointer is pointing at 5, which is at position 1, 1. In the rows collection for position 1, 5 does not exist, so we'll add 5 to it. Similarly for the column collection for position 1, 5 do not exist, so I'll add 5 along with 3. But for the box collection, as this is the first box, 5 already exists over there, so it makes it invalid. So this is where we stop the iteration and return false as the output. This is one way of solving the problem where we are using three collections to maintain the rows, columns, and boxes and making sure the values are unique. With this solution, our time complexity is O of n square, where n is the size of the entire board. The reason it is n square is because we are iterating through all of the elements in the input grid and make sure it is valid. To simplify this further, as we know the size of the board is always going to be 9 by 9, we can change, or we can also say the time complexity is O of 1, that is constant time. Similarly, the space complexity is going to be O of n square, as we are using three collections to maintain if the records or the numbers are being repeated or not. As the size of the board will not change, as that is it will always be 9 by 9, we can simplify it to say the time complexity is O of 1, that is constant space. I hope you are able to understand this approach to solve and check if the board is a valid Sudoku board. Let me show you how we can implement this using Java. In this Java implementation, I have created three collections that will be used to check if the values are unique or not. As it is an array of set, I am running a for loop to initialize each of the entries in the collection. After initialization, I am running nested for loops to iterate through all of the elements in the given board. If the value that I and j are pointing is a period, it means it has an empty cell, so we cannot do any checks. So I'm just continuing with the loop. If it isn't a period, then I'm checking if the value exists at the rows of I collection. If yes, it means the value is not unique, so I'm returning false. If it is unique, then I'm adding C to that collection. I'm repeating the same check on the next line but with the columns collection. For the boxes collection, I'm using the division operation to calculate the box index using I and j values, and then using the result to check if the value that I and j are pointing, does it exist in the boxes collection. If it does not, then I'm adding it to that index. After the for loop is complete and we did not encounter any duplicate, I am returning true as the output. This code, when submitted on LeetCode, beats nearly 79% of the submissions in terms of runtime and 12% in terms of memory. Thank you for watching this video. I hope you are able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.